I'm going to deliver a presentation on slope stability analysis. Yes, slope stability analysis is primarily intended to evaluate the stability of various structures like earth, rockfill dams, embankments, excavated slopes, natural slopes, both in soil and rock. So, what does slope stability means? Slope stability refers to a condition in which in condition of inclined soil or rock slopes to withstand or undergo any movement. This stability condition is a subject of study and research in soil mechanics, geotechnical engineering, and engineering geology. So, generally, our analysis will be aimed at understanding the causes of an occurred slope failure or any factors that can potentially trigger a slope movement resulting in a landslide, as well as we will also focus on preventing the initiation of such movement, slowing it down or arresting it through mitigation counter measures. Having given that a brief, let me go directly to the topic without any delay. This is the agenda of the presentation. So let me introduce the topic a little bit. Earth slope. Yeah, here my topic, my presentation will be focused only on soil slope stability analysis. Our rock slope stability analysis will not be covered, will not be in the domain of our presentation. Earth slope is definitely an unsupported inclined surface and is comprising soil mass. These are the way. Let us all go to these various structures in which these earth slopes are encountered. Yeah, we can see this at transportation. Railway. When railway track is going on, there will be railway slopes. We can see these slopes are little. Uh, Trying to be becoming in a destabilized. We will have embankment which will be constructed for construction of highway. We have earthen embankments and in which we purpose is to store the water. The stability, safety of the entire structure will be dependent upon the slope stability of that earthen dams. Here we have a levee. Levee will be used to regulate the water level in such a way that if anything, any breach occur, there will be a chance of flood and safety will be worsened. So definitely, if you are not considering the stability of your slope, and if you are not uh, giving enough importance to this particular concept, this will be the result. There are several examples in our civil engineering where we have encountered so many live slope failures. You can see one side where road itself has been damaged. Full life was so many lives were affected, or so many losses of life occurred every year due to this slope failure. So this is the important. That's the importance of our topic today. What to be done to uh, keep our slope stable? We have to, obviously, we cannot, the first answer to this question is to keep your slope very mild. But if you keep your slope so mild, you have to, there were so many limitations. You don't have that much space, and we don't have that much budget in our project. Then another extreme is keep it so steep, then our earthwork cost will be very minimum. But very steep slopes definitely will not be stable. So there are two ends. One end is economy, other end is safety. We have to be, there must be a compromise to be made between economy and safety. Yes, slopes provided neither too steep nor too flat. We have to keep the slopes, optimize the slope in such a way that both must not be compromised. So stability of proposed, when we are proposing a slope, it is very essential to check the stability of that slopes. And we have so many modern methods of soil testing and stability analysis with us, which will help us to check the stability of these slopes. Then we will get a safe and economical design of a slope. So, what geotechnical engineer must have a thorough knowledge of various methods for checking stability of slopes and limitations. Generally, failure of soil mass occurs along a plane or curved surface. Generally, it will occur along a curved surface. It will be in a circular shape. A large mass of soil slides with respect to remaining static mass. It's called failure of soil. When does slope failure occur? Answer is when forces causing failure greater than shearing resistance along a critical surface of failure, slope failure will occur. So, what are the factors leading to failure of slopes? One by one, let us see. One is when your shear stresses, that is, the forces causing failure, will be increased, there will be failure of chance of failure of slope. When your shear strength reduction, your shearing resistance is reduced, there is a chance of failure of slope. What are the various factors which increase the shear stresses? Weight of the water, surcharge loads, loads coming from the traffic, from the buildings, railway load, seepage pressure, and we can see that when you steepen the slope by excavation or erosion, then by excavation or erosion, there is a chance of shear stress development. Then that is a one side. Other side is factors causing the shear strength reduction. There is an mobilize there is a inherent shear strength for every soil, but this shear strength may be get deteriorated or degraded. How come? By increase in water content, by increase in the pore water pressure, by shock loads, cyclic loads, weathering, and rainy season will cause further destabilization, further seepage, and presence of water both cause both increased stresses and strength loss. So we can see that there is one factor which is common in both in increasing the stresses and reduction of the shear strength, that is the presence of water. So, considering all of this, my last two slides, we can point out what are the factors in considering method of slope stability analysis. Yes, soil type is a very important factor. We have to consider that. We have to substantiate whether soil type by proper classification, whether it is clay soil, whether it is silty soil, sandy soil, and dimension and geometry of the slope is another factor. Height and gradient of the slope. Gravitational factor will also play an important role in considering the method of slope stability analysis. Pore water pressure is another aspect to be studied and to be analyzed for considering the method of slope stability analysis. Tension crack is a crack which will generally develop due to the tensions within the soil material at the surface. This is also to be studied, and with are the various types of analysis. This all things need to be studied and to be detailed before going to select the method of slope stability analysis and vibration or earthquake. So let us go through various scenarios of this shear strength reduction and shear stress increasing enhancement. Let us go to the first figure. Steepening of earlier the slope was here, original stable slope, and suddenly we have steepened the slope. How did it happen? By erosion. Then there is a the slope itself was reached, have attained a stable slope by mobilizing itself. In second, there is one scouring. Due to scouring, slope gets destabilized. Due to rainfall, water will be filling the crack, tension crack. This causes seepage force to develop, and this further reduce the shear strength. Earthquake definitely will cause destabilization of the slope. Movement, geological feature like soil stratification will cause, which is another important factor which is to be considered in slope stability analysis. Yes, at the crest of the slope, there may be overloading. This is also another aspect which must not be missed out during the slope stability analysis. Any excavations going to happen at the top of the slope will automatically destabilize the top slope. A reservoir, this stresses due to this reservoir operation or reservoir water will affect the movement, will affect the slope stability. And this water level in the reservoir is always fluctuating depending upon the water availability, and high water level to low water level. That process is called rapid drawdown. At that time, the restraining water force will be removed. This due to that, stability of the slope may be affected. Groundwater seepage is another aspect which is to be given importance during the slope stability analysis. So, in all these ways, we can summarize the observations or deductions which we made in the last previous slides. A formula, a factor of safety is equal to available shear strength by mobilized shear strength. This factor of safety, in other words, in a layman's definition, factor of safety is equal to available shear strength by or resisting strength resistance by your destabilizing forces, resisting the shear strength by destabilizing forces. Or one more, if you go to further very, very simplified definition, it is factor of safety is equal to strength shear strength of the soil by stress developed in the soil, the destabilizing stresses. So we can express our factor of safety in various ways. General definition can be given. With respect to cohesion, we can given. With respect to friction, also can be given. This is the general formula which everyone may be familiar in civil engineering. Factor of safety is equal to tau F by tau D. Tau F is equal to C dash plus D dash sigma dash tan phi dash. Tau D is equal to C dash D plus sigma dash tan phi D. Factor of safety. Tau F is average shear strength of the soil. Tau D is average shear stress developed along the potential failure surface. When we are expressing factor of safety with respect to cohesion, the same thing will be going to C dash by C dash D dash, phi dash by tan phi dash D dash. These are the various definitions for factor safety. So in soil, most of the soil will fail in a circular in a circular geometry. This is a shape of the slide surface. Why slide surface will always find the line of least resistance. This least resistance will always be the slide surface. This slide surface takes the form of a circle, and most stability theories in soil slope stability theories based upon this observation. Obviously, circular failure happens when individual particles are very small compared with the size of the slope. This failure is rampant in soil, very much uncommon in rocks. So this is the symbolic representation of the circular failure, in which we can see that all the standard methods will divide this circular sliding surface into so many slices, and we do analysis of every slice by method of equilibrium. In this way, we will find out the factor of safety. This is another important aspect in soil slope stability analysis. That's various methods available for soil slopes. Ordinary method of slices by Felenius, Bishop modified method, Jambu, Morgenstern and Price, Spencer. These are the main keywords which you might be very familiar in soil slope stability analysis. Felenius, Bishop, Jambu, Morgenstern and Price, Spencer. Morgenstern and Price method is a very common method, the most common and most general method which we use, regular method which we use in field for slope stability analysis. Each method has its own advantages and disadvantages. We can say that with high it is felonious method will not be efficient when we are using stress analysis with high pore water pressure. Bishop method, again, it's more accurate than felonious method, but it is we can do hand calculation, spreadsheet calculation. Jambu method also applicable to non-circular slip surfaces. Morgenstern and Price method is very accurate. All slope geometries and all soil profiles, this method is applicable. Rigorous, well-established, complete equilibrium procedure. Spencer method, it's again the same. It is very much simple method, and it's more or less like Morgenstern, more or less have the same features of Morgenstern and Price method. So it's very difficult nowadays to go ahead with standard handy calculations or spreadsheets for slides method of slides. What we do, we will depend upon our software. Any software which has the algorithm developed on all algorithm specific to every method, we will depend upon that software. One of them, so many softwares are available. There are two common softwares. One is GeoSlope Slope W, and other is Rock Science Slide. Today, I will just go through focus on the Slope W software developed by Geo Studio. And this software is the leading slope stability software for soil and rock slopes, where rock will fail as in the form of very highly weathered rocks. Slope W analyzes both simple and complex problems for a variety of slip surface shapes, pore water pressure conditions, soil properties, and loading conditions. And Slope W has nowadays many features to analyze almost any slope stability problem.